Hi, we are going to start a new chapter called Momentum, and I call it chapter 4.5 because it is rather short, and also I actually made up the chapter number. Because if you try to check the textbook, you find out momentum is actually in chapter 2, all right, which only like 4 pages in total. And so why do I do it this way? Why do I skip momentum earlier and now finally doing it and call it chapter 4.5 is you can only understand momentum and appreciate the system of momentum after you learn energy. Before we start, let me ask you to do a prediction using what you have learned. So here I've got a setup which there's a tennis ball connected by a string hanging in the middle. So let's just call it M1. Here I've got another ball which this guy is going to move up and release it here. Okay, let me call it M2, and in fact they are all the same, right? So both M1 and M2 is of exactly the same mass because they are simply identical. And so here what we are going to do is we'll have the ball set up here at 80 cm tall from the base. The base is like where the first ball M1 is. And then we are going to release this ball. Okay, when we say release, that means the initial velocity is 0. We release from at rest, and then because of the gravity, of course, it will try to swing down, and this is like the path, the trajectory that it will go through, and eventually, as you can tell, this M2 will hit M1. All right, they will collide to each other, and we actually put some tape on the ball, and so they were stuck together, and they will both, okay, imagine these two balls will both move together to a certain height. Okay, and so what I'm asking you is predict what happened, as in how tall they will be going up to. And there are 4 options. You can say 10 cm, 20 cm, 30 cm, or 40 cm. So try to use what you have learned in energy and try to predict what happened. Pause the video now.
A few moments later.
Alright, so let me try to show you how we can do it using energy to predict. So once again, we have both ball. One is M1, one is M2, and in fact the mass are the same. And we have M2 released at 80 cm from the reference line where the M1 ball is. And so initially you will have GPE, right? And then when you collide with this ball, it will be like they will simply move together, and then to a certain height that is, say, H. All right, okay. And so if this is H, then that is the GPE that they will obtain at the end, and so that will be the GPE 2, I will call. And since they are not moving, right, when you go to the highest height, you stop moving, right? That's why it's highest height. So I call it GPE 2 in this case. So we just have to simply substitute the equation, which is mgh. Here we've got m2 gh as in 80. All right, or you can keep it as h first, maybe h2 maybe. And then on the other side, it will be also mgh, but then this m is going to be m1 plus m2 g times the new height, okay, or the final height, whatever symbol that you use. And so here we've got m2, which is, let's just put it as m, and then for m1 plus m2 is going to be 2m, okay, because again they are identical. G, I'll keep it here. H will be 80 cm, so I'll keep the unit as cm and then substitute this as 80, and then I will want to find h prime, the new height. And so obviously, oh sorry, I've missed out the g as well. And so obviously what you can do is you can cancel out the m on both sides, cancel out the g on both sides, and eventually you find out 80 equals to 2h prime, and therefore the new height should be 40 cm. Okay, so this is what you learn from the energy chapter, those equations and the idea of conservation of energy told you that eventually these two balls will go up to 40 cm. Let's check the answers together. A moment of truth. In 3, 2, 1. Can you see that? It went up to only 20 cm. And you may say, oh my god, our physics doesn't work. We have violated the law of physics. Of course, it is not, right? Our physics still hold. Let me give you 10 seconds to think about why. Why the ball cannot go up to 40 cm as we expected using the idea of conservation of energy. Why it can only go up to 20 cm only. Think about it. Alright, here is the answer. Think about this. When the ball M2 try to collide with M1, during the collision, as you can imagine, whenever you try have a collision, you have a sound, right? So there must be a sound whenever you collide. No matter how soft it is, there is still a bit of sound energy for sure. And so in this case, some of those energy from GPE or even the KE, since it's moving at a certain speed, will be transformed into sound energy. So the sound energy here is the one that taken the energy away from the ball and is going to be dissipated in the surrounding. And that's why these two balls wouldn't have as much energy when they go up, and therefore can only reach up to 20 cm only. And so that is why we need to introduce you the new concept called momentum, because this may help us to predict using another approach to the same scenario, and this may give us a better prediction. And in fact, using momentum, I can tell you, you can predict the result as in 20 cm, exactly like what it happened. So I'll leave this question just now, that demonstration, as a question that I'll come back to you later on. So whenever you feel comfortable, after maybe later on a few videos later, feel free to come back to here by yourself and try to re-evaluate this question again using momentum and see if you can derive the answer as in 20 cm. I'll see you again and tell you more about momentum in the next video. Bye.